So, welcome back. This is going to be the next part about learning about radicals. So, in this one, we're going to be converting them. And so, what does that mean? Well, there's actually a couple of different ways that we can write radical functions that we have not seen before this. So, this is like totally new, totally different. Okay, so let's start talking about this. This is just our radical sign. Our radicand here is x. And let's say that this now has an exponent on it. Okay, there's an exponent on the radicand. Now take a breath because you're like, oh my God. No, it's cool. Everything will be fine. Then this out here is still an n. That's our nth root, right? Okay. So there is a way to write this without the radical signs. You can actually write it using rational exponents. That means there's going to be a fraction in the exponent. So let's talk about what that looks like. In order to convert it, so that's what we're going to call it, converting, we're going to take our radicand, or sometimes we call that our base, when it's in this exponential form here. That's our base. And we're going to take the exponent of m. It is going to become the numerator, and the nth root, or this n over here, is going to become the denominator. So there's a reason we do this that you're going to see in the next video, but I wanted to keep them kind of like short. So this one's just kind of like bite size, showing you how to convert it. So if you're given something like this in radical form, our base comes over here. That's the radicand. Our exponent that's on there moves to the numerator, and our nth root is our denominator. So again, this is going to come in handy when we actually solve equations, because sometimes it's easier to write something in one way versus another. Okay, so let's actually just practice doing this. So first example, we will do 6 to the 1/2. So I'm actually starting in this format now. You see the base. You see I have a numerator and a denominator. So I can write this with a radical. I'm going to draw my radical sign. And my base is 6. That's my radicand. Now, typically what we would do is put the exponent on the 6 and put the nth root on the outside. But you probably, I'm assuming, have never seen a problem that looks like that. That's because, just like everything else that we do in class, oftentimes mathematicians like to simplify it, and this is not its simplest form. Both of these things are assumed. I know that's going to bother some of you. Sorry. This 1 doesn't actually have to be written, because when we don't have an exponent written, we assume it's a 1. And this 2 doesn't have to be written, because when we have a missing index, it is assumed to be 2. I know there's a lot of assuming going on. So what you're actually going to see is just the square root of 6. That's it. You're just going to actually see the square root of 6. Okay. Now, does that happen all the time? No, that happens when we have an exponent of 1 and an nth root of 2. That's what the simplest form would look like. All right, so number 2. Okay, let's start in the other format, and we're going to do the 4th root of 512. Okay, so base stays the same. So my radicand comes out here, got 512. Now, you might be thinking, well, wait a minute, there's no exponent, it's 0. No, we just talked about this. When you don't actually see it, it's a 1. So that becomes my numerator, and 4, your nth root, is my denominator. So when you go to put this stuff in big ideas, you can put it in either way. If you want to put the 4th root of 512 in, you're going to get the same answer as if you put in 512 to the 1/4. They are equivalent. They will give you the exact same answer. So big ideas asks you for different ones. You can put that in Desmos however you would like.